Hi guys, welcome back. So you guys did topic 6, which is volume of pyramids and cones. Well, topic 7 now talks about surface area of pyramids and cones. Okay, so let's go ahead and do that. And I can tell you that this is pretty much just gonna be easy, I would think, in that there are two formulas that needs to be used for this. And believe it or not, the two formulas are plain and simple. And I think it is easy by using these formulas to go ahead and and do the surface area. Okay, so we have a pyramid for the surface area for a pyramid. We have that it's going to be 1/2 of capital P, and capital P stands for perimeter of the base. So this is something new. You need to do the perimeter of the base. You add everything around, multiplied by the slanted L. Slanted L is the slanted height of the shape of the pyramid or the cone. Okay, slanted L. In some cases, they use an S, like a slanted S, and it stands for slanted height, and then plus capital B. And remember that capital B, it stands for area of the base. Okay. So there's many things you have to do in this case to be able to find the surface area. So again, perimeter, you got to have the slanted height. You take half of that and then you add it by the area of the base. Okay, area of the base. And we're going to do some examples with that. Now, if we look at the cone, remember the base is a circle, so definitely you're gonna have pi r square. That's the area of the base, and then you're going to do you're gonna add pi r l, and the L again is the slanted height. Okay, in this case, I have it as a like a capital L, but it's the slanted height. That's what it stands for. Okay, now the pi RL is it's what what it's another name. What it's called is the lateral area. Okay, so if you have a case where they ask you what is the lateral area, lateral means the side. Okay, so lateral area, and there might be tests that you might have either in the SAT or anything else. And luckily, you guys are not taking the EOC. But if they were to ask what is the lateral area, well, you only concern about pi RL. That's it. Just around it, right? Not the base. Okay, because lateral means the side, not the bottom part. Okay, so that's it. Those are the two formulas that you're going to use to find the surface area. So let's go ahead and let me take you to the next page where we have, I have two examples that we can do. And the first one we have, notice you have that the length is 20 and the width is 20. So in this case, it's a square pyramid. And then we have the height of the pyramid. Notice they give you the height, which is 13. And they also give you the slanted height. Okay. Notice what we're going to need here is in our formula, what we need is the slanted height. We do not need the regular height. So we need the perimeter of the square. We need the slanted height. We need to multiply that by the slanted height, which is 16.4. And then we need to divide that by 2. And then we're going to add the area of the base. Okay. So notice again, the base is a square. So to find the area, just to find the big B, right? To find the area of the base, we do 20 times 20, which is 400 meters square. So we have that. So we got big B. The perimeter is 20 on each side. So 20 times 4 is 80. So we have the big P. That will be 80. And then the slanted height, we know that is 16.4. So we got the height, which is the slanted height. And then all we have to do is divide that by 2. Okay. So you do 80 times 16.4, which is perimeter times the slanted height, divide that by 2, and then we multiply that by 20 times 20. Okay, and I made a little mistake here. I noticed that I need to add this to the area. I need to add, not multiply. Notice I did not put the plus sign. And this is a big mistake here, right? I need to add 400. So once I do 1312 divided by 2 is 656. So I need to do 656 and I need to add 400, not multiply. Okay, I made a mistake there. So my answer is going to be completely different. So it'd be 656 plus 400, which I will get 1056. 1056. Okay, and that is it. This is how you find the surface area for, in this case, is a square pyramid. Now let's go for a rectangular pyramid, which is the same example we done before for volume. Is a 10 by 8. So to find the big B again, area of the base, going to be 10 times 8, which is 80. We have that right here. Then the perimeter is twice. That's 10 and 10, that's 20, right? So we have 10, and then we have 8 and 8. Altogether, we're going to have 36. So this is big P, perimeter. The slanted height. What about our slanted height? Well, our slanted height we don't have. Now, notice they give you the regular height, which is 6. And if I draw a right triangle going in this direction, because the whole length is 10, that means that half of it will be 5. So this will be 5. Okay, so now I have the shape of a right triangle, which I did it over here, right? And I did it in this direction, as a matter of fact. I did it in this direction, it doesn't matter, but you have a right triangle. So this would be 5. The height is 6. Notice I drew it over here, 6 and 5. So you use Pythagorean theorem, and to find out what C will be, you have A and B. In this case, it's 61. So you do the square root of 61, which it gives me 7.8. So that means that my slanted height of this is 7.8. Okay. And notice, I believe I put it over here already. I put the height, the slanted height. No, the slanted height is right here, 7.8. Okay. So then again, we're going to do for the surface area, we're going to do the perimeter. And the perimeter, what do we have for the perimeter? The perimeter is 36. 36 is right here. Multiply that by my slanted height. That's my L, which is 7.8. Then I'm going to take half of that, and half of that, it gave me, half of that is 140.4. And I need to add the area of the base. Notice I made that mistake here again. Okay, I made that mistake. I'm not supposed to multiply, I'm supposed to add it. Add the area of the base, and area of the base, which in this case was 80, so plus 80. So this is also incorrect, okay? And I just realized that. So we have, so it's going to be 140.4 plus 80, which gives me 220.4, 220.4. And this will be the surface area for this pyramid that is a rectangular pyramid. Okay, and that's it. So let's go to a cone. And when we look at a cone, we go again with this formula right here, which is area of the base, which is a circle, pi r square. Then the lateral area, which is pi r L, and L is the slanted height. Again, okay. So if we have this cone right here, for example, number 1, the first thing we need to do is area of the circle, which is pi r squared. Notice we have the pi, the radius is 2, so square that, and we get 1256. Okay, now, so that's the area there. So I already got pi r squared. Now what do I need to do? I need to add pi r L. Well, I need the slanted height. Notice I do not have the slanted height, the L on the side. Okay, I don't have that. So I need to use Pythagorean theorem again to find the slanted height. And if I do that, I get 8.2. So that means that this height is 8.2. And I'm going to go ahead and multiply 3.14. Okay, so I'm here, 3.14 times the radius. The radius in this case is 2 times 2. And C, which is the slanted height, is 8.2. Notice at the beginning I have pi r squared, which I already did that. So now, and I got this correct, notice what I'm doing is I'm adding IRL, which is the lateral area. So I'm adding 12.56 plus 51.5, and my surface area will be this much, okay? So that is it. Now in this case, remember, I needed to find the slanted height because I need it in my formula and I didn't have it, so I used Pythagorean theorem. There will be some cases where they give it to you and you don't have to look for it, okay? It all depends what's missing. But just keep in mind that with these pyramids and cones, if you are missing any of those length, it forms a right triangle coming from top to bottom and to the side. It always makes a right triangle. Okay, so this is where Pythagorean theorem becomes very useful, and that is it. As far as the IXL that you have to do, it's plain and simple. What is the surface area of the triangular prism? So you use the formula, okay, that you have. And in that case, notice the base. The base is a triangle, okay? So you got to use that as the base. And we go from there, okay? I don't think for this one I'm going to go through it because I already explained it to you enough. And I don't want to make this video to be too long. I just want to show you just to see if I see anything strange that you might, I see that you might have issues with. And so far, no, I don't see anything. Notice this cone, they give you the slanted height. The slanted height is 15. So if anything, if you need the height, you need to find it by drawing a right triangle, okay? Right triangle. But in this case, you don't need it for the cone. What you need is the slanted height, okay? So if I take it to the next step, pretty much you have the radius, you have the slanted height, and you don't need the height, right? You do not need the height. And they tell you to use 3.14 and round to the nearest hundredth. So be careful with to the nearest hundredth, okay? And that is it. Just make sure you take those two formulas, write them down on a piece of paper so you have them handy, and you go from there. And that will be it for this video.